Let's look at this last problem. Let's start with the domain and the range. So as I look at this problem and I analyze it from left to right, we can see consistently we have some part of the function, closed dot, open circle, it's consistent, hold on, it's consistent, closed dot, open circle, and this will continue to move up and to the right. So consistently from left to right, it doesn't stop here, it's going to consistently move up here at a diagonal. The domain is going to be from negative infinity to positive. Now the range is difficult. The range is definitely difficult. So for this problem, for the range, let's start at the bottom. And this arrow means it's going to go down and to the left. So consistently as I'm moving up, I'm examining from left to right. I always see some part of the function all the way up to a y value of -1, and we have a closed dot. So all the way up to -1, and it's closed. I'm writing that in as right there. Putting that in as a bracket. We're going to include that. Now look at this. After I go past -1, it's blank space in here, and so I need to be able to identify that on the range. So there's nothing, there's nothing, there's nothing, all the way up to 5. Now when I get up to 5, after I move forward after y equals 5, I will consistently see some part of the function. But at 5, we have an open circle. Increasing, decreasing, and constant. Okay. Well, let's start off with the easiest one. The easiest one is constant. Remember that constant, increasing, and decreasing always are going to have parentheses, and we're going to read them from left to right and also describe it in terms of x values. So in terms of x values, x equals -1 all the way to x equals +3. -1 to +3. It's constant between those endpoints. Okay, from left to right, this is increasing, and from left to right, this is increasing. So there is no decreasing. There's none available. Let's look at the two increasing. This first one comes from the far left. Comes from the far left, and it continues to decrease all the way up to an x value of -1, an x value of -1. Okay, this is an x value of +3, and as I move to the right, it continues to increase. As I move to the right, it continues to increase after it leaves an x value of 3. Where are the y values positive and where are the y values negative? So let me darken this in here. This is the only portion of this piecewise function that has positive y values. So how do we describe this in terms of x's? All right, so at x equals 3, notice there's an open circle, so it's not positive at 3. But as I move to the right along this piece of the function, it will always be positive. If this had been closed, then I would have put a bracket to include the 3 as being in the positive portion. These are the two negative parts. It doesn't matter which one you describe first. Let's start with this one. It comes from the far left, and it's negative all the way up to an x value of -1. Now at -1, I am going to put a bracket because see how this is a closed dot? So I need to include it as showing it's part of the y values that are negative on the graph. Okay, this constant region of the graph goes from where x is -1 all the way to where x is +3. -1 has an open circle, so I'm not going to include it as being in the y negatives or f of x negative. And we have a closed dot at x equals 3. We're going to include it. Oops. This should have been right down here in the negative portion. Okay, let's go to where f of x is, or f of -5 is. So let's find -5. I go straight down, and the output is -5. Let's find -1. So -1 straight down. It just happens to be -1 as well. Let's find 0. Here's 0. The output is -4. And let's find 3. 3. Okay, I go to the closed dot, which also is at -4. All right, let me write the end behavior. As I go to the very far left part of the graph, very far left part of the graph, notice how this is going to go into that oval and it's headed down. Headed down is a negative infinity. I'm going to make my circle here. Eventually this piece of the function would creep into that oval and it would be headed up, which is positive infinity. This particular piecewise function has no x-intercept, so you could write diagonal as this, and a, or I got this empty set. look at the y-intercepts. There is one y-intercept. Remember, some of these will have just one y-intercept at most, so this will be at 0, -4.